So let's talk about the work that we can do with fractions. So with fractions, what we're dealing with is a numerator and denominator. The numerator represents a part, whereas the denominator represents a whole. So like the idea of 2/3, most often we represent this with a circle. It's the idea it doesn't even have to be a circle. I can show this with a rectangle too. But so if we cut that up into thirds, then what this is representing is thirds represents the whole. So I have these 3 pieces of the whole, and we have 2 parts of it. So that would be a visual representation. Like I said, we could do a rectangle, and if we cut that up into thirds, so we have our 3 pieces of a whole, and we have 2 of them, so 2/3. So let's talk about some vocabulary here. One is going to be the idea of an equivalent fraction. So it's a fraction that's exactly equal to the value we're given. We're just making it look a little different. So how we do that is we're going to take our fraction 2/3. And to make an equivalent fraction, what we do is we multiply the numerator and denominator by the same value. So like if I multiplied both by 5, and really what I'm doing here, if I separate that up, it's like I'm multiplying by 5/5, which when you divide by the same thing, that's just equal to 1. So what I often call this is a version of 1. It's just a version of 1 that helps us get to where we're going. So if I do this, 2 times 5 is 10, 3 times 5 is 15, and this is my fraction. And the idea is that 10/15 is exactly equal to 2/3. Because all we did was multiply by 1, we just kind of chose a different version of 1 that helps us change the numbers a bit. But the idea is that if we went to a calculator and typed in 2/3 and got a decimal out, that's going to be the same thing as 10/15. So at a decimal level, exactly the same. So what we want to do here, so that's a little side piece there. So 2/3, and we want to create an equivalent fraction. So we want to multiply both the numerator and denominator by the same number. They have to be the same. And we want a denominator of 12. So in the denominator I have 3. So what do I need to multiply it by to get to 12? I need to multiply by 4. And if I multiply the denominator by 4, I have to multiply the numerator by 4 as well. Have to be the same. So 2 times 4 is 8, and then over 3 times 4 is 12, and that answers our question exactly for this equivalent fraction with a denominator of 12 that is equal to 2/3. Again, if I went to my calculator and did 8 divided by 12, there is my 2/3 in decimal form. So equivalent fractions, multiply the numerator and denominator by the same value. Now, simplifying fractions is the same idea, but just in reverse of how do we take something that's kind of more complicated and simplify it. So what that would look like is if I have this 8/12, that's kind of a more complicated form of the fraction, where we talked about multiplying both the numerator and denominator by the same value. This would be thinking about dividing the numerator and denominator by the same value. And typically we try to find the largest value that we can put in there. So like I could divide both of these by 2, that would work. But what I want to see is that I could go even further than that and divide both by 4. So if I did 8 divided by 4, that's 2, over 12 divided by 4, which is 3, and this is the simplest form of that fraction. Now, if I had only done division by 2, notice that if I go divided by 2, that would give us 8 divided by 2 is 4, over 12 divided by 2, which is 6. This is not a simplified form because there's still more that we could do. We could divide by 2 again, and then that would get us to 2/3. but then 2/3 would be our simplified form because there's nothing else that we can divide out from both the numerator and denominator. So we'd really like to take out the largest value from both, but if you can't see that largest value, you can do it step by step by divide by 2. Here we would just divide by 2 again. You just have to keep going until it's completely simplified. So here we're simplifying the fraction 10/6. Something I want to point out with this fraction, so notice that the numerator is larger than the denominator. This is called an improper fraction. It's just the case where the part that we're covering is larger than the whole. So the idea is we have these 6 pieces. In fact, I can go ahead and give a visual for this. So if I divide up into 6 pieces, I have to do thirds first, and then I'll cut those in half. So we have these 6 pieces, but we have 10 of these. These each represent 1/6. So the idea is I need 6 of them, and then I need 4 more. So if I draw my picture over here, sorry, not perfect, but good enough, is that here we have 6 of those 6 pieces, and then we have 4 more to represent 10 of these 1/6 pieces. So an improper fraction goes beyond just one whole piece, and then we have some extra. Now, what we could actually see from this is we can start to see our solution a bit. If you think in terms of thirds, like here we have 3/3, here we have 2 more thirds. So really I have 1, 2, 3, 4, 5 thirds. So I could start to see that visually here. But in terms of calculation, like I was describing up above there, so we want to divide by the same number, and we want to try to grab the largest number that we can. It looks like 2 is going to be our value here. So 10 divided by 2 is 5, over 6 divided by 2, which is 3, which is exactly what we talked about up above there. And then I just double check that there's nothing else that I can divide out from both of them. So this 5/3 would be our simplified form. So that's a visual of it, but really we think in terms of dividing out the same value from both the numerator and denominator. All right, multiplying fractions. If you have some fraction, let's say I have a fraction a over b, and I'm multiplying with some fraction c over d, what we do is we just multiply the numerators, multiply the denominators. So in the numerator, I would have a times c over denominator b times d. So I'm going to show this one in 2 pieces, but just following that rule, what we would have is in the numerator 6 times 7 over in the denominator 7 times 12. And then we could just plug that into a calculator, and that would give us 42 over 84. Then what we want to do is simplify. We want to put this in a simpler form. So what I could recognize is that 42 is exactly 1/2 of 84, or you could think of that in terms of I can divide both the numerator and denominator by 42, which would give us 42 divided by 42 is 1. 84 divided by 42 is 2. So this is equal to 1/2. Now, as you can imagine, as these numbers get more complicated, so does this fraction here. It can get very messy. It can be hard to determine what values can divide out from both the numerator and denominator. And that's where I want to show you another way of going about it. So what we could do is go to that stage of where we have 6 times 7 over 7 times 12. And what we can do in this stage is simplify. What we're doing is looking for factors across the numerator and denominator that divide out with each other. And I know I'm showing a lot of different ways here, but there's also a lot of different ways to approach this. So I'm even going to split into 2 different ways here as well to show you how we can go about this. There's kind of the short way and the long way, and just a matter of which you're more comfortable with. So the short way is just looking for pieces that you can divide out across the numerator and denominator. So like 6 and 7, there's nothing common to divide out there. But 7 divided by 7, those just cancel out with each other. That just makes a 1. So what we could do is cancel those out, and it's like it's leaving 1s behind. And then what I could see is 6 divided by 12, where there's a common factor of 6 there. So 6 divided by 6 would just leave us with a 1. 12 divided by 6 would leave us with 2. So I can see as in the numerator, I just have 1 times 1, which is 1, over 1 times 2, which is 2. So that gets us there. So it's just a matter of thinking of things you can divide out from both the numerator and denominator. And it's just easier to visualize in this form here rather than that 42 over 84. Seeing the breakdown of it, you can see the piece a little more easily. Now, the long form is called the prime factorization. This is usually a good starting point for simplifying fractions. So if you haven't done it a lot, this could be a good route to go. The idea is breaking down these pieces as far as we can into prime numbers, which means you can't divide anything else out except for 1. So like instead of writing 6, what I would do is I would write that as 2 times 3. So it's equivalent to 6, but both of those numbers are prime because there's nothing else to divide out. And then we have times 7, which 7 is prime. There's nothing else to divide out there, so we're just left with that. Over 7 times, and then 12. So what I start doing here is I think, okay, 12 can be divided by 2, and that leaves me with 6, which can be divided by 2, which leaves me with 3, and the 3 is prime, so I leave it like that. So this whole 2 times 2 times 3 is exactly equal to 12. It's just all in prime numbers. And now what I can do is just start crossing like terms out. Meaning I have a 2 up here, so I can take a 2 away from down there. I have a 3 up here, so I can take away a 3 down there. I have a 7 up here, so I can take away a 7 down there. So then all that I'm left with, well, up in the numerator, everything canceled out. So really I just have a big 1 left over. And then the denominator, I have a 2 left over. So I would have a 1 over 2. So that would get you there as well. So a lot of different routes to the same answer. I am going to show this form most often, but if this is confusing, the prime factorization can be a good breakdown form to really see how everything's canceling out. So how we can see that we are left over with a 2 down there. All right, let's look at another example. So what I'm going to do here is I can go one step further if it helps to write 6 times 10 over 5 times 12. And without multiplying anything out, I'm going to start canceling. So I see my 6 and 12, which has a common factor of 6. So 6 divided by 6 leaves a 1. 12 divided by 6 leaves a 2. And then I have a 10 and 5. And if it even helps, there's a few different routes to go here. Maybe you're recognizing, well, that's a 5 times 2, which is 10. So really this is turning into a 10 over 10. So maybe you see that at this stage. This is just 10 over 10, which is equal to 1. That works great. If you're going this route of canceling even further, maybe we'll go, okay, 10 and 5 have a common factor of 5. So 10 divided by 5 leaves us with a 2. 5 divided by 5 leaves us with a 1. So in the numerator, we end up with 1 times 2 over in the denominator 1 times 2, which would also get you to that final answer of 1. So with these, it's just a matter of simplifying until it's in its simplest form. It doesn't have to be the shortest route. You can keep simplifying down until you get there. Just take the steps you need in order to get there. Just to show you another example with prime factorization, let me go ahead and show that here. So with 6, I would rewrite that as 2 times 3 And then we're multiplying that with 10, which is 2 times 5, over, let's see, we just have a 5, and then 12 is going to come from, okay, divide by 2 leaves us with 6, which is 2 times 3. And then if we start canceling, what you'll see is just everything cancels out. That numerator is exactly the same as the denominator. So when everything cancels out like that, a common mistake is to write down 0. However, the idea is that our numerator is exactly the same as the denominator, which means dividing by the same thing gives us 1. So just be sure with these cancellations that 1 is coming out, not 0. 0 comes out from addition, subtraction, but multiplication, division gives us 1. All right, one last piece here is with division. So if we have two fractions, say I have a over b, and I'm dividing by another fraction, c over d. What I want to do is change this into multiplication, because thinking about dividing with fractions is really hard for the brain. So a little phrase I like to use here is keep, change, flip. So what this means is we have three pieces here. It's like we have this first fraction, the division, and then the second fraction. This is what we're going to do keep, change, flip with. We keep the first piece, so a over b, that fraction, stays exactly the same. We're going to change to multiplication, so where I see division, I'm now going to write the multiplication symbol. And then flip means take that second fraction and flip it. Flip the numerator and denominator so that they're in the opposite locations. And then we have multiplication, which we can just use what we did up above there. So let's try this with this first example. And if it helps, you can write this as 12 over 1 and then divided by 3/4. So what I'm going to do is keep, change, flip. So I'm going to keep the 12 over 1. I'm going to change to multiplication and flip 3/4 so that now it's 4/3. And then we simplify. So let's see, that 4 divided by 3, there's nothing to simplify there, but 12 divided by 3 can simplify to a 4. So we're going to have 4 times 4 is 16 over 1 times 1, which is 1, which we can just write as 16. All right, let's do another example here. 3/10 divided by 1/2. So we're going to do keep, change, flip. So I'm going to keep 3/10 exactly the same, change to multiplication, flip to 2 over 1 instead of 1 over 2. And then simplifying, there's a common factor of 2, so 2 divided by 2 is 1, 10 divided by 2 is 5. So 3 times 1 over 5 times 1 for 3/5. So that's multiplication and division there. With multiplication, just go across the numerator, go across the denominator. For division, you want to take this extra step to change it to multiplication. And to do that, you need to do keep, change, flip.